Roshni, and it's a quick recap of Unit 3, First Order Logic of Artificial Intelligence. So here I can show you what Unit 3 comprise of. These are the most important topic. Uh, so FOL actually it you can describe in three parts. It works on predicates, functions, and quantifiers. Predicates describes properties of the object. Functions describes, or I would say maps objects to one another, and quantifiers reason about multiple objects, right? So, to understand this, first we need to know how we are representing the statements to logic. So you can see there are four examples. These are the main examples which we use for all the statements. All A's are B's for all X. AX implies BX. Some A's are B's. There exists some X, AX, and BX. No A's are B's. For all X, AX implies not negation. This is a negation symbol, negation of BX. Here you can see how to write simple logic. Like, for example, there is a P is a person. We write it like this. Person in braces, there is a P. P is a person. We read like it. Now you can see we have existential quantifier represented as like this, universal quantifier. We call it for all A, there exists some. So how to convert a statement into this first order logic? So this is a simple example. The statement is there is a person that everyone else loves. How would you convert it? So firstly, write P is a person, and we need to make a logic to there is a person. For that means there exists some person, and now we'll be making logic for next sentences. So there P is a person, and that everyone else loves. How we define everyone else? So there's for all Q, and there's a person. Q is a person, and P which not equal to Q. So all P is not loved by all Qs. That means loves Q loves P. So there is a person that everyone loves, everyone else loves. So that's how not equal to Q is there. Now you can see here, what are the equivalence rule? This is one of the two of the most important rule. If we are doing negation of P and Q is equivalent to P implies negation of Q, and negation of P implies Q is equivalent to P and negation of Q. Now we need to understand very important table. You can see it in Zoom. What is that? When the value is true, which one is false and true? For all x, px. So for all choice of x, px, it is true. For some choice of x, negation of it's not true. There exists x, px. For some choice of the x, it is true. For all choice, it is not true. For all x, negation of px. For all choices of negation of px. For some choices, it is px. It could be x is a p. There exists x. That means negation of px. Some choices of x, negation of p. For all choices of px. This is simple, but that is very useful. Now come back to this. So sometimes we refer the terminology horn clauses and definite clauses. What are those? So in simple terms, we can define definite clause as a clause which is a disjunction of literals with exactly one positive literal is known as definite clause or strict horn clause. And where is horn clause? A clause which is a disjunction of literals with at most one positive literal is known as horn clause. Hence, all the definite clauses are horn clauses. For example, it has only one positive literal k, and it is equivalent to p and q implies k. So this is negation of p or negation of q or k. So this is, for example, how we can represent it. So Now the next thing comes when that is important is the question comes like we are getting a statement and we need to convert it, we need to create a resolution graph. So what are the important step? So first step, one of the step is to convert a statement into first order logic, which we have covered here. And there is a conversion to CNF form. So these are the basic rules one should definitely know. So how to eliminate double implies. So double implies can be written as F implies G, and this is slash, actually this is a slash. G implies F. Eliminate single imply, negation of F and G. This R symbol, what you're seeing, it has it is an AND symbol, actually it is coming incorrectly here. Okay, I'll just update this later. So you know how to eliminate double negation. You should also know distribute or over and. Now I take an example. Remove implication. Summer or snow or the bizarre. Push negation inwards. This is a De Morgan law. How do we start with remove double negation and distribute or over and? Now let's understand the example. That would be, for better understanding. So we have got a question using a predicate logic. Convert the following sentences to predicates and prove Ram did not jump is false. So Ram went to temple. The way to temple is walk till post box and take left to right road. So these are statements we have given. So we start, how we start to make a resolution graph here. We starts with negation of the statement needs to be proved. So Ram did not jump. Negation of jump, Ram. Convert given statement to FOL first. So how would you do it? The first statement, Ram went to temple. Ram at temple. The way to temple is walk till post. X, X at the way, anyone X at temple. For all X at X temple implies X needs to go to post box, right? So X at post box and take a left, right? For all X, next is left road has a ditch. For all X at temple implies X at postbox and take right. This is for the second statement or statement B2. So for the ditch is this one. The left road has a ditch, takes left and it crosses, X crosses ditch. Way to cross the ditch is to jump. X crosses ditch implies jump. Log is across the right road. X take right, X at the log. And now one needs to jump across the log to go ahead. X at log implies jump X needs to jump. Now the second step after converting all first order logic, we need to convert it to CNF form. This is simple. The formulas we use uh, at X temple, at X post box, negation over we like for example this implies, for all implies we are converting it to the or. This you can see at X, this one. So once we are able to find till the logic converted to CNF, we can try writing uh, proof by resolution. You can see simple here. Negation of Ram jumped. This we have can start. And first one is at X log jump here at X log or jump X. Now start with here. We can replace X with Ram at Ram log this one. This one. Take right x at x log. Here, x is substituted by Ram. Take right. We'll cut it from this. Take right. Now at X temple, take right, done. At X temple, at Ram temple. This is first statement, at Ram temple. This is negation, hence proved. That's all from this is simple one, but sometimes we get confused which one to take first and how to convert it into a CNF form. So you can go through one more time in detail if you want. Yeah, that's all from my end.